Okay, welcome to Chapter 9. This is going to be very different than a lot of stuff we've done so far this semester. It's like learning a whole new language, trigonometry, in a chapter. So it's a huge deal. All right, so let's start off on page 462. Okay, this is right triangle trigonometry. Okay, you've heard of SOHCAHTOA before, right? The sine of an angle is the opposite over the hypotenuse, the cosine of an angle is the adjacent over the hypotenuse, and the tan of an angle is opposite over adjacent. Well, we're going to take that, we're going to expand it more. In fact, that sign should look familiar, and we write sin and then theta. We don't use x as our variable, we use theta when we're talking about angles. Cosine, this is how you spell it. It's also on page 462. COS, theta. So we write COS, but we say cosine. And then tangent, and then we write tan, we say tan, or we say tangent, theta, okay? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tan is opposite over adjacent. You need a copy down on page 462. In the yellow box, there's the core concept. So copy that down because it has some more information. And also right above the core concept, that is how to spell the words, and you need to listen to the pronunciation so that you can say them right. We're not saying sin, we're not saying cos, okay? We're saying sine, cosine, tan, and at some point you should pause to copy this down. So when you're done pausing, the new stuff is, and it's pronounced, so say it with me, cosecant, and we write CSC of theta. Secant, SEC of theta. We don't say sec, we say secant, but we write SEC, theta. And cotan, COT, we don't say cot, we say cotan, theta. Okay, so that's the new stuff. And you'll notice that these are the reciprocals of the previous three functions that you should remember from geometry. Okay, and it's just the reciprocal. Okay, before we get started with page 463, number 1, there's a couple things I need you to write down because I need you to memorize them. If you memorize them, everything else is going to be easy. You're going to see these numbers over and over again. So at some point, pause and copy this down. And I hope you just paused and you started up again. So what you're going to do is say out loud 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. These are your Pythagorean triples. If you see a right triangle and there are two legs, one leg is 3, one leg is 4, then the hypotenuse has to be a length of 5. If you see a combination of two legs, 5, 12, the hypotenuse is 13. If you see 7, 24 for the legs, then the hypotenuse is 25, and so on down the list. Likewise, if maybe you see only two pieces of information, for instance, you see that one leg is 8, the hypotenuse is 17, then you know the other leg is 15, and you don't have to use the Pythagorean theorem to find it out. Also, for 45, 45, 90 right triangles, you should know that it's x, x, x rad 2. Leg, leg, hypotenuse. If a leg is x, the other leg is the same exact value, whatever that x is, and then the hypotenuse is that value times rad 2. And for 30, 60, 90 right triangles, leg, leg, hypotenuse, x, x rad 3, 2x. If this is the shortest leg, the longest leg is the same is x times rad 3, and the hypotenuse is the shortest leg times 2. Okay, copy this down. If it's a complete foreign language right now and it doesn't jog your memory, that's okay. You're going to have practice, but you need to have this down and refer to it over and over and over and over and over again. All right? Now, let's see how to put this into action. We are on page 463, and we'll do number 1 together. So they give us a right triangle, and they tell us that there's a leg of 3, a leg of 4, and they're telling us what theta is. Okay, this should actually look familiar. In fact, this is the first Pythagorean triple. So you could spend the time and write, all right, 3 squared plus 4 squared equals c squared, and take the square root. So 9 plus 16 is 25. The square root of 25 is 5. You could spend your time doing that, but I'd rather you didn't. I'd rather you just know right away after practice and memorization that it's a 3, 4, 5 right triangle. Now, they're telling us where theta is. So you need to pretend that you are backed into this corner right here. You're standing in this corner and you're looking out. Okay? Now, it tells us to evaluate the 6 trigonometric functions of theta. Here's how I want you to keep it organized every single time. I don't care if the computer has you type it in differently. You, on paper, need to organize it this way. There are patterns and ways to eventually intuit the work. We're going to make 2 columns. The first column is going to be sine, cosine, tan. Okay? We'll have equal signs, and we're going to figure out what the simplified fractions are. Over here, across from sine, that's where we're going to put cosecant. Across from cosine, that's where we're going to put secant. And across from tan, that's where we're going to put cotan. Okay? So 2 columns. First column, sine, cosine, tan, the familiar ones. Second column, right next to them with a space for the answers for sine, cosine, and tan, cosecant, secant, cotan. Remember, this symbol is theta. That's our variable. That is the angle where we're at. Okay, so we are standing in this corner right here where theta is, and we're looking straight opposite us. Okay, so straight opposite, sine is opposite over hypotenuse. Cosine, we're standing in this corner, and we need to do adjacent over hypotenuse. Adjacent is the wall, that's not the hypotenuse, that you can touch. If you're standing right here, you can touch this wall. So the cosine is adjacent over hypotenuse. And then finally, the tan is opposite. So where are we looking? 3. What wall can we hit? 4. Opposite over adjacent. Okay, one of the previous whiteboards, I said that these are reciprocals. So cosecant is not the opposite over the hypotenuse, but the hypotenuse over the opposite. Secant is not the adjacent over the hypotenuse, it is the hypotenuse over the adjacent. And then finally, cotan is not opposite over adjacent, it is adjacent over opposite. So if we keep this nice and organized with sine, cosecant, cosine, secant, tan, cotan, if we keep it organized like that every time, we'll actually skip a step instead of thinking about it. If we did this column correctly, we can take the reciprocals, simplify your improper fractions when necessary, not necessary here, these are all simplified, and we have our answers. These are the 6 trigonometric functions for this right triangle. Okay? Pause if you need to, rewind if you need to. I'm going to move on to number 2, and we're going to do the same thing, step by step, nice and organized. So for number 2, on page 463, they give us a right triangle, and it maybe looks familiar to you already. Oops, and I did that wrong already. This is good because it gives you time to copy it down. They give us a right triangle, they put theta in the top corner, they give us a hypotenuse of 17 and one leg of 15. Okay, so let's use our Pythagorean triples. Which one does this line up to? We have a hypotenuse of 17, one leg's 15. If you guessed it correctly, good job. The other leg is going to be 8. And yes, it does turn out that 8 squared plus 15 squared does equal 17 squared. You have calculators that can do that. You take the square root of 17 squared, you're going to get 17. Okay, directions say evaluate the 6 trig functions. So that means we make 2 columns automatically. Sine, cosine, tan, cosecant, secant, cotan. Okay? All right, so we are in this corner right here, and we're facing opposite us. We're facing straight out. Oh, out. Oh, opposite. What is opposite? 15 over the hypotenuse. We are in this corner, and it's adjacent. Cosine is adjacent over hypotenuse. What wall that's not the hypotenuse, if we're standing in this corner, can we slap? That's 8. 8 over 17. Finally, Tan, opposite over adjacent, 15 over 8. And since we're organized, cosecant is the reciprocal, so 17 over 15. Secant is the reciprocal of cosine, 17 over 8. And cotan is the reciprocal of tan, so 8 over 15. No fraction needs to be simplified. Improper fractions are perfectly fine. And here we go, the 6 trig functions of an 8, 15, 17 right triangle where we're standing right here. There's where our theta is. Okay? All right, let's do something that's going to require a little trip down memory lane. And it might have been something that you struggled with in geometry. If it is, don't worry. You're older, you're wiser, you're smarter. Number 3, I want you to kind of think in the Wayback Machine, what kind of triangle is this? Okay, they give us this triangle. One leg is 5, the hypotenuse is 5 times rad 2. If we go to our list over here, what hypotenuse ends in rad 2? All right, so if one leg is 5, the other leg has to also be 5 because both legs are the same value, whatever the x is. And then look over here, 5, 5, 5 rad 2. That's what we have. So we now know that this side is 5, okay? So I want you to not wait for me. If you can, go ahead and fill in your 6 trig functions, and you can check with me about simplifying. You might need to do some work on the side. So sine, cosine, tan, cosecant, secant, cotan. All right, so we're standing up here. Our sine is opposite over hypotenuse. So that's 5 over 5 rad 2. All right, that's not simplified though. We can take out a 5, right? That simplifies to 1 over 1 rad 2. All right, but if you remember from a previous chapter, you're not allowed to have a radical in the denominator. So what do? We have to multiply by what we don't want over itself. We don't want the radical in the denominator, so we multiply by rad 2 over rad 2. 1 times rad 2 is rad 2. Rad 2 times rad 2 is 2. Sound familiar? So our simplified fraction, the only acceptable answer is rad 2 over 2. Okay? Cosine theta. I bet you it's going to be something similar. Cosine adjacent, also 5, over hypotenuse, also 5 rad 2. Well, guess what? I already did the math. 5 over 5 rad 2 is going to simplify into rad 2 over 2. Tan of theta, opposite over adjacent, 5 over 5. That simplifies to 1. My only acceptable answer for tan of theta. Okay? All right, now we need to do reciprocals. So I could take the reciprocal of this, but I'm going to have to do some rad 2 over rad 2 stuff. Let's see if I can skip that. So rad 2 over rad 2, that's up here, right? Before I simplified it, this is what I had, right? This is what I had to rationalize. So what's the reciprocal of 1 over rad 2? Well, it's just rad 2 over 1. Not going to write the over 1. Secant of theta, again, rad 2 over 2 is the cosine. What is the reciprocal of rad 2 over 2? It turns out to be rad 2. And then finally, this is easy. What's the reciprocal of 1? It's 1. Okay? So for our 45, 45, 90 right triangles, or our x, x, x rad 2s, or our 5, 5, 5 rad 2 triangles, the sine is going to simplify to rad 2 over 2, cosine is rad 2 over 2, tan is 1. Cosecant is the reciprocal of this, it's rad 2. Secant is the reciprocal of this, it's also rad 2. And the reciprocal of 1 is 1. Okay? That's number 3. If it was a lot, pause, rewind, think back to rationalizing denominators. I know it might have been a long time ago. We did have practice as the year went on. All right? Definitely something that is doable with practice. Okay, I believe there's number 4 before we get out of here. So, for number 4, they tell us that we have a right triangle. It says in a right triangle, you should be looking at your book with me because it's a word problem, sort of. In a right triangle, theta is an acute angle. All right, so draw the right triangle and put your theta. All they mean is they're saying theta is not your 90-degree angle, okay? It's an acute angle. It's less than 90 degrees. The cosine of theta, okay, so it doesn't really matter where you put theta as long as you don't put it in the 90-degree spot. The cosine is 7 over 10. Evaluate the 5 other trig functions. Well, I want you to have all 6 listed down. So they tell us that we have a right triangle, we have a theta somewhere. Doesn't matter where you put it. We know that the cosine is 7 over 10. So that means adjacent is 7, hypotenuse is 10. Is this one of our triples? And the answer is no. There's no hypotenuse of 10. So we are going to have to use the Pythagorean theorem. Let's say that a squared plus 7 squared equals 10 squared. So a squared plus 49 equals 100. A squared equals 100, take away 49, so 51. A equals the square root of 51. All right, well, let's see. What's the biggest perfect square that goes into 51? 4? Nope. Is it 9? Nope. 16? Nope, because 4 doesn't go in there. 25, 36, 49, nothing goes into rad 51. So that is our A. Rad 51. Okay. Now, it says the 5 other trig functions. And again, you know, if you're submitting something online, you're going to do what the online wants you to do. However, if you're writing it down on paper, which you need to do the work, you're going to write it down this way to save yourself some trouble. Oops, sorry. Cotan. Okay. So let's see. They tell us already that the cosine is 7 over 10. So what's the secant? Good. 10 over 7. All right, now what's the sine? If we're standing here for our theta, our very messy theta, opposite is rad 51 over hypotenuse, that's 10. What's our tan? It's opposite over adjacent. Our adjacent is 7, so rad 51 over 7. Okay, so sine is rad 51 over 10. Cosine is 7 over 10. They gave us that. Tan is rad 51 over 7. Secant is the reciprocal of cosine. That's 10 over 7. All right, cosecant. I need some more whiteboard space. So we're going to take the reciprocal of rad 51 over 10. I hope with enough training and practice from earlier in the year, you can regurgitate it right now. But if not, let me do the math for you. But eventually, you're going to need to regurgitate it and not do the math every time. Okay? So we're taking the reciprocal of rad 51 over 10. Okay, so that's 10 over rad 51. But I don't like the rad 51 in the denominator, so I have rad 51 over rad 51. What's on top? 10 rad 51. What's on the bottom? Just 51. Does anything simplify with the 10 and the 51? The answer is no. So what is my reciprocal of, and here's where I want you to regurgitate. What is the reciprocal of rad 51 over 10? It's 10 rad 51 over 51. There's a pattern. So I'm going to write another color because this was a very math-intensive problem. 10 rad 51 over 51. Okay, so likewise, you can do the math on your extra spot. We're taking the reciprocal of rad 51 over 7. If we follow the pattern, 7 goes on top, rad 51 goes next to it, and just 51 goes in the denominator, and that is the answer, 7 rad 51 over 51. So here's our 6 trig functions for this right triangle. All right, this was a long video, but I took my time to go through it because we're starting a new language, trigonometry. It seems different, and it is, than a lot of the stuff that we're doing, and it's going to take some time to learn the new language, just like it takes time to learn French or Spanish or Korean or Japanese or Hebrew or German or whatever. All right, so tune in for the next part.